Excellent. All right. Hello, everybody. I hope that we're doing great. I know it's probably been 19 hours or so of people watching talks so far. Hey, so I'm Cole. I've already had a bit of an intro. I also recently started my own company, but we're not here to talk about that. We're here to talk about some fun stuff, basics, right? So why talk on basics? It's so OWASP, right? I figured that we have like probably 1,000 talks beforehand that were all focused on really technical topics, whether it's flagship things or artificial intelligence or developer education. Yeah, heaps of geniuses before me have talked about lots of stuff. And I know it's late in the day for all you folk in the US, so I thought we'd cover something a little bit easier. Let's go to the basics, right? So, you remember the days when you're told that computer science is where you do science, but you kind of got computers. It's like nothing like this at all. We sit there, we learn the good things, we smile, we giggle to each other. Afterwards, we head over to the pub after like 2 hours of hard, riveting lectures about algorithmic complexity, play some beer pong, and then I think that's like my recollection of what university kind of was, but it's probably more like this actually. And I think, I was coding beautiful menus like this to help us achieve our assignment goals, right? And look, it could have just as easily have been blocked out by this, but I'm sure that we've all been in this situation before, right? Where we've all been coding if menu equals one, if item equals one, if value equals pizza. Terrible, terrible code. So what I want to cover this talk is literally basics. So very simple things, stuff that you would have learned very early on in your careers. Because doing your basics well leads to more secure code. I'm going to give a shout out to Reddit, the subreddit Bad Code, because I found lots of great examples there. So I hope you're going to have a bit of fun here. All right, so first thing we need to do is have clarity. High dive into frozen waves of the past comes back to life. So unless it's pretty clear, I can't sing, right? That was clear. But you know what's not clear? This code. I don't know what's going on here. All this, like, what is this chess game? I think. And then you get stuff like this. It's absolutely amazing, right? But also completely inscrutable. If your code is inscrutable, you cannot assess its security posture by looking at it. Sure, you can run automated tools to attack it, but I think a lot of bugs are more easily found by just looking at the code and talking to engineers, right? And inscrutable code is everywhere. It's all over the place. If you worked in any bank or telco or even modern tech companies, you'll come across weird Yoda expressions and things that no one understands, right? Like, look at this. This is a regular expression. We love those. Input validation. It's great. So I think I see an @ symbol in there. I hope you do. I don't understand the rest of it. It's a bit too complex for me. This one's for an IP address. Who knew that it could be so bloody complicated, right? I feel like I have no idea what I'm doing when I'm dealing with irregular expressions that are so crazy complicated. And I'm not alone. Like I found this on the Bad Code Reddit. So this fella here says, this puts commas into a number. Example, 1,000 goes to 1,000 with commas in it. And his next line says, I pulled this from Stack Overflow and I have no idea how it works. This is why I prefer to use expressions that are a lot clear. So if it's inscrutable, you don't understand what's necessarily going on. So in this case, we have postcodes in Australia. I don't know, because this is a global audience, but postcodes in Australia usually have just 4 numbers and that's it, right? So for me, I prefer to use the top expression, even if the bottom expression is technically correct, because I at least understand what's going on in the top one. But there's plenty of other areas where clarity is key. Like naming conventions. Hey, position, 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 public entity, position dot position, position, position equals position. Come on, guys, what is this? Oh, the line, the one line that does everything, you know, the one line, the rule of all, and in the darkness bind them. Or that one method that does literally everything as well. Yeah, that guy. So look, lesson number 1 is that clear code is easy to understand, all right? It's easy to change, and it's easier to scrutinize, all of which are really important for doing a security review. If you don't know what's going on, or you're afraid to make a change to it, what's the point of doing the assessment, right? So I'm not saying like go crazy with being super explicit. There's a difference between clarity and being explicit. You don't just like put 1,000 burrs or overly comment everything available on Earth. So this is a 101 course, right? So let's move on to our next constructs. Iteration and selection. So there was a talk just before me about AI. I figured that this is a good representation of it. Okay, joke time over. All right, so programs like to iterate. It means doing something over and over and over again. The definition of insanity, I guess. As security folk, we want to kind of control how often we do something, right? So it can come in the form of like having our code loop endlessly, iterating until it just stops working. Or it can come in the form of recursion, like we see on the right with the billion laughs attack. Main thing is that, I guess we also want to, we sometimes let our applications have a little bit too much data come in through them from users. So we don't want them to get overwhelmed either. So recognizing when your program is exhausted, whether it's been running indefinitely, or it's expanding a dodgy XML file, or you just haven't been rate limiting users from sending packets your way, got to make sure to pay attention to that stuff. It's easy to just iterate forever and not really have a way to stop the program from executing. And then that will cause a denial of service. Then we got selection. Yeah. If, else if, else, switch, catch, all of those fun keywords. So sometimes programs can appear quite linear. So you go to the blue switch palace and go straight down and you're done with the forest of illusion. But like what appears linear often has a lot of extra complexity or paths that are available that you might not immediately be aware of from your first glance at a program, right? So if statements are a fantastic place for bugs to hide. They're innocuous, everyone uses them, and they're usually okay. So like in this situation, this is for a relatively recent hack. It's Kaseya. Does anyone, can you see the problem with this source code here? I'll give you a moment to have a little bit of a look. All right, time up. You see the red arrows? Yeah. So besides the code being a little bit inscrutable, because really there are 5 methods for authentication up top, what's going on there? So they fail open with an else statement. And that's something that's very easy to miss because static analysis tools don't have context. So this one is another derp from a fortnight ago, actually, not too long ago. So it's we check to see if we have an authorization header first, right? Well, let's just say that we don't have an authorization header. We're going to ignore all the code up the top. Don't worry about that. And then we end up down this path here. So we check it out, and then we have a statement about whether the handler's auth failed before we actually go in there and return an error code, right? Well, I mean, if you look at the constructor, yeah, computer science 101, constructors, it shows that the auth failed variable is instantiated to false by default. So we go back to that code. Yep, that doesn't happen. So what are we left with? Yeah, just the process authorized message, which is also known as the "oh my god" vulnerability about 2 weeks back. So about some management interfaces in Azure, might have heard of that. So it's why I'm a fan of structuring code in this way instead, front loading your error states to the beginning of the method. If it's quite clear about what your requirements are for validation, for authentication, for authorization at the very top. And as long as you sequence them correctly on a per method basis, it's hard to make mistakes like we saw in the previous slide. And you're much less likely to write code that's crazy like this. Quick talk. So there are lots and lots of basics in the world. You already know to probably look at variables now, see how they're constructed and what they can contain. You can look at things like truthiness in JavaScript. You can look at like short circuiting conditions as well. I can't cover everything in 25 minutes. And I know you're all probably a little bit tired after watching such a long conference. So let's sum up. Clear code is easy to understand. If you know what a programmer's intentions are, you're starting from a great baseline for security. If the code is brittle and hard to change, how can you fix any security defects, right? Clear code is reliable and you can make changes and see how they work. And you want to have code that you can scrutinize. As much as I love the obfuscated C code contest, I don't like trying to review that kind of stuff. It's not fun, hurts my brain. I have a tiny, tiny brain, not a galaxy one. So, and yeah, basically any efforts to scrutinize code that's been deliberately obfuscated are really time intensive. So try to make it easy to read. So your basic constructs matter as well. Don't just glance over if statements, for loops, while, switch, try, catch. All of those present opportunities to create business logic flaws. All right. So anyway, happy 20th anniversary OWASP. I'm Cole Cornford. Quick fun talk, lighthearted, easy. Hope you've been having fun with Back to Basics. Class dismissed.